In this last section, I want to look at and review some of the reactions that we've talked about so far. And I basically have four-ish kind of questions. So here we have CH3, bond C, bond OH, bond H, bond H. And we want to do a multi-step synthesis where we end up with CH3, CH, double bond, CH2. So we go from an alcohol to an alkene, and as usual, I've chosen small molecules. So how can we do this? Well, one thing that we learned was we could add double bond CH2 in place of a carbonyl carbon. But right now we have an alcohol. So we could do the Wittig reaction if we had an aldehyde. How can we turn this primary alcohol into an aldehyde? Well, that is where we use Dess-Martin. So we're going to use Dess-Martin bariadenane. All right, and that will stop at a single oxidation and yield the aldehyde. Now, if we want to replace this with a C double bond CH2, because now we have CH3, CH. Now we need to replace this with this, we can use Wittig. Okay, so we're going to use PH3, double bond CH2. In the next three examples, we're going to use acetone as the starting material in all cases. And we're going to do three different things with the acetone. So here we have CH3, C double bond O, CH3. In this case, what we want to convert it to, and these are just one-step syntheses because in all cases, I didn't want to make a bunch of them where you just had to prepare aldehydes and ketones through oxidation first. Okay, let's look at how we could turn it into this molecule. CH3, C double bond N, CH3, CH3. Now in this case, it seems fairly straightforward, right? We have to add a nitrogen. But you got to remember that it's not quite that straightforward because we have to decide, do we want to add a primary amine or a secondary amine? In order to end up with the imine with an I, we need to add a primary amine. So we should use NH2 CH3. If we used NCH32 NHCH32, we would end up with a double bond here and then two CH3s on this. We would end up with the N amine. Let's look at the next couple. There's two more left. We're going to, again, in all three of these cases, going to start with acetone, C double bond O, CH3. And this time, we want to turn acetone into propane. To get rid of this, we use the Wolff-Kishner reaction, and that's going to use hydrazine. H2NN, H2, okay, in the presence of KOH to make this reaction happen. Finally, we have CH3, C double bond O, CH3, and we want to make this molecule. CH3, C bond OH, CH3, CH3. What's the difference between these two molecules? Well, I've converted from a ketone into an alcohol, and I've also added a methyl group, which means I needed that methyl group to attack and kick that up there. What is the way to get an alkyl group here? The way to get a methyl group is Grignard. So CH3, MgBr in ether, and H3O+. So after we've covered about half the material for this course, I hope you can see that there is some advantage to understanding the mechanisms. Because if we're going from here to here, we know that we have to have a nucleophile come in. Here we didn't really cover the mechanism. And here the mechanism is quite complicated, but at least you can see that this was acting as a nucleophile and coming in here. How we lost the oxygen is slightly more complicated. So that brings us to the end of this chapter.